Dear students, in this video, I'll explain you what is a discrete random variable. First of all, I'll explain you what is a random variable and types of random variable and the problems on discrete random variable. In the probability theory, we know what is a random experiment. Okay. When we conduct the experiment under the similar conditions repeatedly, its outcome is not known. We know the result of the experiment in advance, but when we conduct the experiment, its outcome is not sure. Such experiments are known as random experiments. For example, tossing a coin. If we toss the coin, head may turn up or tail may turn up. But when we toss a coin, we are not sure about either head is turning up or tail is turning up. Such experiments are known as random experiments. The set of all possible outcomes of a random experiment is known as sample space. Here we are discussing random variables. Random variable is a function. It assigns a real number to every sample point in the sample space according to some rule. That random variable is also known as stochastic variable. Random variables are usually denoted by x, y, z, etc. Once again I am repeating. Random variable is a function. It assigns a real number to each sample point in the sample space according to some rule. Okay. That variable is known as random variable. The set of all values taken by the random variable is known as the range of the random variable. For example, when a coin is tossed twice, what are the possible outcomes? The sample space is in both the tosses, head may turn up, or in the first toss head, second toss tail may turn up, or in the first toss tail, second toss head may turn up, or in both the tosses, tail may turn up. This is the possible outcomes of when a coin is tossed twice. This is the sample space. And x is the random variable. It is a rule. That rule is number of heads in the outcome. Okay. So, x assigns a real number for h as 2 because there are 2 heads. X assigns the value 2 for h. And here there is only one head in ht. So, x assigns the value 1 for ht. Similarly, for th also there is only one head. So, x assigns the value 1 for th. And x assigns the value 0 for tt because there are no heads. So, it assigns the value 0. X is the random variable. It assigns a real number to each sample point in the sample space according to the rule number of heads in the outcome. So, x takes the value 2, 1, 0. This is known as the range of the random variable. So, range of x is equal to 0, 1, 2. Okay. This is a random variable. I hope now you understand what is a random variable. Okay. For tossing a coin, the sample space is HH, HT, TH, TT. X, a random variable. It assigns a real number to each sample point in the sample space according to some rule. That rule is number of heads in the outcome. Here, the rule is number of heads in the outcome. So, x assigns the value 2 for HH, 1 for HT, 1 for TH and 0 for TT. Hence, x is a random variable. The set of values taken by the random variable is known as the range of the random variable. Range of x is 0, 1, 2. It is a finite set. And for the same sample space, we can define any number of random variables. Here we define only one random variable. Or else the y is the number of tails turn up. We can define another rule y the number of tiles turn up, or Z is the random variable. Okay. For if head turns off in the first task 1, otherwise 0, there is another random variable. We can define any number of random variable for a single sample space. Okay. Now I hope you understand what is a random variable. Random variable is a function. It assigns a real number to each sample point in the sample space. Okay. According to some rule. Now we'll see the types of random variables. There are two types of random variables. One is the discrete random variable, another is continuous random variable. If a random variable takes finite or countably infinite number of values, then it is called discrete random variable. Otherwise, it is known as the continuous random variable. If the range of the random variable is finite, then it is known as discrete random variable. Otherwise, if the range of the random variable is non-countably infinite, then it is known as continuous random variable. Okay. If a random variable takes non-countably infinite number of values, then it is called a continuous random variable. Okay. Next, discrete probability distributions. Okay. To define what are discrete probability distributions, we should know what is a probability function. Okay. First, I'll define a probability function. Look at this. Usually, we are denoting the random variables by capital X, Y, Z, etc. If for each value xi of a discrete random variable capital X, we assign a real number p of xi or p of x such that p of xi is greater than or equal to 0. Simply we can also write this as p of x. And second condition is summation I is equal to 1 to n, p of xi is equal to 1, or summation of p of x is equal to 1. Then the function p of x or p of xi is called a probability function. Look at this. For tossing a coin, okay, the random variable x is number of heads in the outcome. Range of x is equal to 0, 1, 2. For each value taken by this discrete random variable x, we can assign a real number p of x such that p of x is always greater than or equals to 0, and summation of p of x from I is equal to 1 to n. In this case, it is I is equal to 1 to 3 is equal to 1. Such a function p of x is known as the discrete probability function or probability mass function or probability density function. P of x is known as the probability function or probability mass function or probability density function. Okay, I hope you understand what is a probability function. Now, the set of values xi comma p of xi, that is the values taken by the random variable along with the probability function is called a discrete probability distribution. Systematic representation of the values taken by the random variable along with its probability function is known as the probability distribution, discrete probability distribution. Okay. And here I define the what is cumulative distribution function. It is not required, still I am defining. The distribution function f of x defined by f of x is equal to summation I is equal to 1 to x p of xi, x being an integer, is called cumulative distribution function. Cumulative distribution function. This is very, very important to you. Mean, variance and standard deviation. Okay. If x is a discrete random variable, discrete means it is taking only a finite number of values along with probability mass function p of x or p of xi, then mean is represented as mu and it is defined as summation I is equal to 1 to n xi into p of xi. This is the mean, or simply we can also write this as summation of x into p of x. This is the mean of the discrete random variable. And variance is defined as summation I is equal to 1 to n xi minus mu whole square into p of xi. Usually we are using the formula variance is equal to summation of x square into p of x minus mu square. Mu is nothing but summation of x into p of x whole square. Okay. Usually we are using this formula. V is equal to summation x square into p of x minus mu square. And standard deviation sigma is equal to square root of variance. Mean of the discrete random variable is defined as mu is equal to summation x into p of x. Variance V is equal to summation of x square into p of x minus mu square, and standard deviation sigma is equal to square root of variance. Now we'll see few problems on this discrete random variable. A coin is tossed twice. A random variable x represents the number of heads turning up. Find the discrete probability distribution of x. Also find its mean and variance. For tossing a coin twice, the sample space is HH, HT, TH or TT. So x assign the value x, a discrete random variable x represent the number of heads turning up. There are 2 heads, it assigns the value 2, 1 head, it assigns the value 1. 1 head, once again it assigns the value 1, no heads, so it assigns the value 0. The range of x is 0, 1, 2. Now, probability function also will find. Probability that x taking the value 2. There are 4 possible values, okay, 4 outcomes are there, 2, 1, 1, 0, and x assign the value 2 only once. So, the probability that x taking the value 2 is 1 divided by 4. 4 outcomes, 2, 1, 1, 0. 4 outcomes are there. X taking the value 2 only once. So, probability that x taking the value 2 is 1 divided by 4. Probability that x taking the value 1. Once again, there are 4 outcomes, but 1 is assigned twice. So, favorable outcomes is 2. Probability that x taking the value 1 is equal to 2 by 4, nothing but 1 by 2. Similarly, probability that x taking the value 0 is 1 by 4 it is. Okay. So, discrete probability distribution is x takes the values 0, 1, 2 with the corresponding probability values. Okay. Probability that x taking the value 0 is 1 by 4. Probability that x taking the value 1 is 1 by 2. Probability that x taking the value 2 is 1 by 4. Look at this. Each of p of x is greater than or equal to 0. And summation of p of x definitely is equal to 1. 1 by 4 plus 1 by 4 is 1 by 2. 1 by 2 plus 1 by 2 is equal to 1 it is. Now, mean is equal to summation of x into p of x. Summation of x into p of x means 0 into 1 by 4, 0 plus 1 into 1 by 2, 1 by 2 plus 2 into 1 by 4 is 1 by 2. 0 plus 1 by 2 plus 1 by 2 definitely equal to 1. That is the mean. Variance is equal to summation of x square into p of x minus mu square. Here I have written the x square values. 0 square is 0, 1 square is 1, 2 square is 4. X square into p of x. 0 into 1 by 4, 0, plus 1 into 1 by 2 is 1 by 2, plus 4 into 1 by 4 is 1, minus mu square. Mu is 1, 1 square is also 1. 1 minus 1 gets cancelled. Variance is equal to 1 by 2. Okay. Very simple problem. Definitely they are asking one problem on the discrete random variable. A random variable x has the following probability function for various values of x. X is minus 2, minus 1, 0, 1, 2, 3 with the probability function 0.1 k, 0.2, 2k, 0.3 k. Find the value of k. Second one is probability of x less than 1, probability of x greater than or equal to minus 1. Okay. Listen to the problem. A random variable x has the following probability function, okay, for various values of x. The values taken by the discrete random variable along with the corresponding probability function they have given. We need to find out the value of k, also probability of x less than 1, also probability of x greater than or equal to minus 1. Okay, how to find the value of k means, because p of x is the probability function, okay, the condition of probability function is, okay, each p of x value must be greater than or equal to 0 and summation of p of x must be equal to 1. 0.1 no doubt it is greater than 0, 0.2 greater than 0, 0.3 greater than 0. Okay, only the thing is p of x greater than or equal to 0 only when k must be greater than or equal to 0. And second condition is, if we add all these values, its sum must be equal to 1. 0.1 plus k plus 0.2 plus 2k plus 0.3 plus k must be equal to 1. K plus 2k plus k is 4k plus 0.1 plus 0.2 plus 0.3 is 0.6 is equal to 1. 4k is equal to 1 minus 0.6. 1 minus 0.6 is 0.4. So that k is equal to 0.4 divided by 4, that is equal to 0.1. That is a k value. Now for k is equal to 0.1, the probability distribution is x take these values. Probability functions are 0.1, 0.1, 0.2, 0.2, 0.3, 0.1 it is. Now, we need to find probability of x less than 1. Which are the values less than 1? Minus 2, minus 1, 0. Or else, we can also write it as 1 minus probability of x greater than or equal to 1. 1 minus, which are the values greater than or equal to 1 means 1, 2, 3. P of 1 plus P of 2 plus P of 3. 1 minus of P of 1 is 0.2, P of 2 is 0.3, P of 3 is 0.1. 1 minus of 0.3 plus 0.2 plus 0.1 is 0.6, 1 minus 0.6 is 0.4. Probability of x less than 1 is 0.4. Or else probability of x less than 1 is also equal to P of minus 2 plus P of minus 1 plus P of 0. If you add this 0.1 plus 0.1 plus 0.2 definitely equal to 0.4. In that way also you can do the problem. Okay. Now probability of x greater than or equal to minus 1. Which are the values greater than or equal to minus 1? Minus 1, 0, 1, 2, 3. Instead of adding all these values, I have written that in the complement way. That is 1 minus probability of x less than minus 1. Which is the value less than minus 1 means minus 2 it is. So 1 minus p of minus 2. 1 minus p of minus 2 is 0.1. 1 minus 0.1 is 0.9. Okay. I hope you understand this. Next problem. The probability distribution of a random variable x is given by the following table. X values with the corresponding probability function. Find the value of k. Probability of x less than or equal to 1. probability of 0 less than or equal to x less than 3. Once again, each p of x must be greater than or equal to 0. Summation of p of x is equal to 1. Okay. Each p of x greater than or equal to 0 is possible only when k must be greater than or equal to 0. And summation of p of x means k plus 5k plus 10k plus 10k plus 5k plus k is equal to 1. Okay, if we add 5 plus 1, 6, 6 plus 10, 16, 16 plus 10, 26, 26 plus 5, okay, 31, 31 plus 1, 32. 32 k is equal to 1 or k is equal to 1 by 32, nothing but 0.03125 you can write. Okay. Now, for k is equal to 1 by 32, probability distribution is x taking the value 0, 1, 2, 3, 4, 5. Here we have okay, in this one, okay, k is 1 by 32, 5k means 5 by 32, 10k means 10 by 32, nothing but 5 by 16. Here also 5 by 16, it is 5 by 30, 1 by 32 total. Okay, that's what I have written here. You can also write this as 5 by 16. Probability of x less than or equal to 1. Which are the values less than or equal to 1 means 0 and 1. P of 0 plus P of 1. 1 by 32 plus 5 by 32. Okay, nothing but 6 by 32. Okay. 2 3s are 2 16s are 3 by 16, nothing but 0.1875. Okay, this is the value. Always you need to remember that probability value is a value always in between 0 and 1 it is. Okay, probability of x is equal to 1. Probability of x is equal to 1 is 5 by 32. And probability of, okay, Here we required probability of 0 less than or equal to x less than 3 it is. Okay. 0 less than or equal to x less than 3 means p of 0 plus p of 1 plus p of 2. Only this much it is. Okay. 1 by 32 plus 5 by 32 plus 10 by 32. Okay. 10 plus 5, 15, 15 plus 1, 16, 16 by 32, nothing but 1 by 2 it is. Not solved it. Okay. But there is the answer. Okay. A fair coin is tossed 3 times. Let x denotes the number of heads showing up. Find the distribution of x. Also find its mean, variance and standard deviation. A fair coin is tossed 3 times. Okay. The sample space is HHH. In all the 3 tosses, head may turn up, or in the first 2 tosses, head, head, next tail, HTH, THH, HTT, THT, TTH. Once again, x denotes the number of heads turning up, showing up. So x assign the value 3 for HHH, 2 for HHT, for HTH 2, for THH 2, for HTT 1, for THT 1, for TTH 1, for TTT 0. So x take the value 0, 1, 2, 3. Probability that x taking the value 0. Totally 8 outcomes are there and 0 appears only once. X taking the value 0 is 1 by 8. X taking the value 1. Okay. Totally 8 outcomes. Okay. And 1 is appeared 3 times. So probability that x taking the value 1 is 3 by 8. Similarly, probability that x taking the value 2 is also 3 by 8. Probability that x taking the value 3 is 1 by 8. Probability distribution is x takes the value 0, 1, 2, 3 with the probability function values are 1 by 8, 3 by 8, 3 by 8, 1 by 8. Mean, mu is equal to summation of x into p of x. 0 into 1 by 8 plus 1 into 3 by 8 plus 2 into 3 by 8 plus 3 into 1 by 8. If I simplify this, it comes out as 1.5. And variance is equal to summation of x square into p of x minus mu square. X square means 0 square is 0 into 1 by 8, 0. Plus 1 square is 1 into 3 by 8, 3 by 8. Plus 2 square is 4 into 3 by 8, 12 by 8. 3 square is 9 into 1 by 8, 9 by 8. Minus mu square. Mu is 3 by 2 whole square or else 1.5 whole square. If I simplify this, it comes out as 3 by 4. And standard deviation sigma is equal to square root of variance. Square root of 3 by 4, nothing but root 3 by 2. If you want, you can also write the answer in decimal values also. Okay. Next problem is, show that the following distribution represent the discrete probability distribution. Find the mean and variance. Definitely p of x is greater than or equal to 0 and summation of p of x definitely equal to 1. Hence, it is the discrete probability distribution. Mean is equal to summation of x into p of x. Okay. 10 into 1 by 8 plus 20 into 3 by 8 plus 30 into 3 by 8 plus 40 into 1 by 8. If you simplify this, it comes out as 25. And variance is equal to summation of x square into p of x minus mu square. 10 square 100 into 1 by 8 plus 20 square 400 into 3 by 8 plus 30 square 900 into 3 by 8 plus 40 square 1600 into 1 by 8 minus mu square. Mu is 25 square. If I simplify this, it comes out as 75. Okay. Similarly, okay, I hope you understand how to solve the problems of this kind. You can do the remaining problems. Okay, we'll end up this. I hope you understand what is a discrete random variable. You need to remember the definition also. Random variable is a function it assign a real number to each sample point in the sample space according to some rule. Next is the probability function. Okay, for each value taken by the random variable, we can assign a real number p of x or p of xi such that p of xi is always greater than or equals to 0 and summation of p of xi is equal to 1. Then the function p of x or p of xi is known as the probability function. Okay, if you remember these two definitions and few problems, okay, how to do the problems, then definitely you are able to do the problems on this. We'll end up this video. Okay.